Okay, so now we're going to come back to what Rory was talking about half an hour ago, and that's interest rate risk. Bonds, when you buy and sell bonds, and you issue bonds, there are investors face two different kinds of risk: price risk and reinvestment risk. And price risk happens because bond values decline when interest rates rise. So if you buy a bond and interest rates go up, the value of your bond will go down. That's called price risk. Reinvestment risk exists because when you buy a bond for 5 years and you have a 10-year investment horizon, at the end of the 5 years, you will have to reinvest that money, and perhaps at a lower rate. So that is reinvestment rate risk. So there's price risk and there's reinvestment risk. So let's look at price risk for a second. What do you notice about that table? You got a 10% bond, the one that was talked about all through the class. And now interest rates go down to 5% or interest rates go up to 15%. One bond's got a 1 year left to maturity, one bond's got 10 years left. What do you notice?
The change in price is a lot higher than the 10-year bond.
The 10-year bond has a much greater swings in price. Why? Conceptually, what's going on here?
Rates can change. There's more coupon payments remaining at the original rate.
Right, so if you've got a 1 year bond, as Jill says, you've got 2 payments left. You've got a 10-year bond, you've got 20 coupon payments left. So conceptually what's going on is that when interest rates change, it has a much bigger impact on long-term bonds because the number of coupon payments affected is a lot greater than in short-term bonds. So long-term bonds face much greater price risk than short-term bonds. And you can see it arithmetically. These are real numbers. This is exactly what will happen if interest rate to a 10-year, 10% bond, if interest rates change to 5% or 15%. So you can see this graphically by the slope of the curve. The prices of the Chartreuse 10-year bond is a lot steeper. The price changes are a lot steeper than it is for the 1-year bond. On the other hand, let's look at reinvestment risk. Reinvestment rate risk depends on both the maturity and the holding period. So I claim that the shorter the maturity, the greater the reinvestment rate risk. Why? What's the basis for that second statement?
With the future coupon payments, I guess by your odds of reinvesting and kind of making up the difference are greater with the longer term you have, just because the market can change or things can improve for you.
Okay, that's on the path of where I want to go. The market can change. So I have a bond today, and I'm going to hold it for 2 years, but I have a 4-year planning horizon. So you're managers of the hospital. You've got you're accruing funds today. You've got a community fundraising campaign because you want to build a new patient tower 4 years from now. You buy a bond for 2 years to invest. You're getting money from the community. You're raising funds. You invest the proceeds, and so that the hope is that when the construction time comes, you'll have the capital you need. So you invest for 2 years. At the end of the 2 years, what happens? What must you do with the principal? You have to reinvest it. What might have happened?
Interest rates could have fallen.
Interest rates could have fallen. So you face the risk that the reinvestment interest rate will be less than current interest rates. So the more frequently you're buying bonds and buying new bonds, the greater the reinvestment rate risk. So long-term bonds have greater price risk. Short-term bonds have greater reinvestment rate risk. How can interest rate risk be minimized? Well, long-term bond, as I just said there, nothing is riskless. What many healthcare organizations will do is match the maturity of the bond to the holding period. So if you know that you're going to start a building project 4 years from now, you'll buy bonds with a 4-year maturity. So that you essentially you eliminate a lot of the interest rate risk by doing that. Okay, the final thing, that 2 weeks from now, you're going to be looking at debt refunding and this was posted on Sakai as well. What's happening at Pardee Hospital? This is last week. People can't see that. What is Pardee Hospital doing?
Restructured.
It's called its bonds. Why has it done that?
Because interest rates are very low right now.
And what will the benefit to the hospital be?
Reinvestment on lower rates.
In the third column, they're going to save $626,000 a year in interest payments. So that is what we talk about as debt refunding or the bond calling decision. But even now, in a period of very low interest rates, there's still quite a bit of debt being recalled. So, any questions about the concepts or the principles of what we've been talking about? Sorry,
Very beginning of class, we talked about the inflation premiums and all that stuff that goes. Is that what sets the coupon rate?
Mm-hmm.
And who sets that rate? Is it the organization or like an independent?
Okay, when an organization wants to issue the debt, it will typically hire an investment banker. And the banker will know what other bonds similar organizations are going for in the market now. But they'll look at your financial statements, they'll assess the risk, probability of default compared to other competitor organizations. That's what you pay the bankers to do, essentially to tell you what interest rate you'll have to pay in the market. And they will find out quickly how good a judge they are at the interest rate, because if no one buys it, it tells you that the interest rate is too low. And if it gets bought up overnight, you're probably paying too much. So it's a big deal for the investment banker to have a pretty good sense of what debt is going for in the market, comparable organizations. Mira.
The example that you did when we were looking at Norton and the other place, what was the definition of yield in that case? Because I thought that
Yield to maturity, as exactly as I just talked about it.
Okay. It seemed a little strange that if, like, let's say that the coupon rate was 5% and the yield to maturity was 4%, that bond would be the one that's at a discount and not at a premium. It seemed backwards, like when we were talking about it. Like if the yield to maturity is lower than the coupon rate, I would think that would mean it would be a discount. Yeah. But I think we defined it as the opposite.
I can't remember exactly what I said, but essentially if the yield is higher than the coupon rate, that tells you that interest rates have gone up, and therefore the bond will be selling at a discount. If the yield is less than the coupon rate, that tells you interest rates have gone down, and the bond will be selling at a premium. Does that conflict with what I said earlier? I hope it does.
So yield to maturity is essentially what the current interest rate is because your bond has responded to the market pressures.
Yes.
Okay.
And you can generalize this all through. I mean, if you had a capital structure which was only debt, then the yield to maturity would be your cost of capital, because it is the only cost of capital, the only capital source you have. So yield to maturity is really the focus of bond financing. It's the current rental rate on debt capital. Other questions? This is pretty tough stuff, so if you want to ask, go ahead. There's an entire course in the business school on this topic, fixed income securities, entire 14-week course, so we're covering a lot of concepts in a short period of time. Julian, did you have a comment, question?
Yeah, I just wanted to, if you could just reiterate when the year to maturity is greater than the coupon.
If the yield to maturity is greater than the coupon rate, that tells you the interest rates have gone up and the bond is selling at a discount. If the yield to maturity is less than the coupon rate, that tells you that interest rates have gone down and the bond is selling at a premium.
Can you say that one more time? Just a little slower, sorry.
So if the yield to maturity is greater than the coupon rate, that tells you the interest rates have gone up since the bond was issued. And therefore, the bond is selling at a discount. If yield to maturity is less than the coupon rate, that tells you that since the bond was issued, interest rates have gone down, and the bond is now selling at a premium.
I'm a little confused about when a bond gets called and how it affects the organization. So let's say an organization issues bonds, 10%, inflation rate goes down, and those bonds sell at a premium on the market. Then how does that affect the organization that has like the fixed coupon rate?
It doesn't affect the organization in the least. Once Chris Ellington issues that bond, gets his $100 million, his interest is over. It's totally over. That's all he has to worry about now is making the interest payments on that debt. However, if you're a purchaser of Chris Ellington's bond, you got to worry. But from the organization's perspective, they don't care. If that's what you're asking.
Then who calls the bond early?
Management calls bonds, well, technically the board would call the bonds, and they would call the bonds if interest rates had a big decline, so that the present value of the costs of getting rid of the current bond would be less than the present value of the interest savings. I'm not sure I'm asking you to answer your, what is the source of your uncertainty? What are you trying to figure out when management would call it, or why, or?
Yeah, I don't know, I'm just kind of confused. I don't know how to proceed.
So they could call it, or they might face a penalty for calling it, right?
There are costs to calling it. This is what the case is 2 weeks from now. There are costs to calling a bond. There's the call premium, there's legal fees, there's all kinds of things that you'll see in the case that have to be dealt with. So you can't just call the bond with cost. It costs money, so it's an investment to call the bond. The issue is whether the interest savings make the cost of calling the bond worthwhile or not.
Oh, okay, I get it.
So if you've got a bond at 10% and rates go down to 9.9%, that won't be a big enough interest decline to pay for calling the bond. You have to have a substantial enough interest rate decline so that the interest savings are enough to pay for all the costs of calling the bond.
Are you usually assuming too that you're going to reissue new bonds at that lower rate?
No, that's part of the case as well, but right now, the issue of whether you want to call the bond or not is yes, you would assume that if you're going to call the bond, then you would replace it with bonds in the case assumes the bonds of the same maturity, just to make it a simpler comparison. In the real world, it may or may not be the same maturity. Good.
It's kind of basic, but could you explain again why, if you were to, you would call a bond if interest rates go down? And so conceptually, why is that? Like you said, a rational manager would only call it if the interest rate goes down.
Right. So you borrow $1,000 from me. Would you rather pay 10% interest rate or 5% interest rate?
If I borrow $1,000 from you, I would rather pay a lower interest rate.
Right. And that's essentially what managers' organizations will face. I've got a bond here that's costing me 10% interest per year. I have the opportunity to get rid of that bond and replace it with a $1,000 bond that requires 5% per year. That's gonna be 5% savings to me as an organization.
Okay.
The lower the cost of capital, the better for me, the lower the cost of my doing my business. The issue is whether the decline in interest rates, whether that gives me enough of a benefit to pay for all the lawyers, the accountants, the premium, and so on that's involved in calling the bond.
Well, I think that telling me this analogy is not right. Is like when people refinance their houses, you know, like interest or mortgage rates have gone down, you're gonna pay fees to kind of go through the refinance, and then you're gonna have lower payments.
Exactly the same. Your parents probably refinanced their mortgage at some point in time. They've made a judgment that their new lower monthly mortgage payments are worth the penalties and the legal fees that'll cost them, that they'll incur in order to refinance the mortgage. Exactly the same issue. Okay, let's try a few questions. We got practice problem 1 here. We've got firm raising capital by selling new bonds. The issuing firm, the coupon rate is generally set equal to the required rate of returns on bonds equal to risk. Is that true or false? It's true. It is. Okay, this one's more difficult. Which of the following statements is correct? Who wants to have it? Call it whatever you want. C is the right answer. All else equals, the bond yield to maturity increases, its price will fall. Yield to maturity is the going rate of interest on that bond in the marketplace. That's the price we observe. You go right to the internet and see what the yield to maturity is on publicly traded bonds anytime. So if it's going up, and the price of the bond will fall.
We
Fine.
talked about A on that one too.
Right?
We just talked about A and why it's not.
What is the interest rate, what is the current yield on a zero coupon bond? Zero. There is no coupon. That's why it's called zero coupon. So it's all capital gains. There's nothing but capital gain yield. There's no coupon yield. There's no current yield in a zero coupon bond at all. Okay, practice problem 3. True or false? Sorry? It's false. Callable bonds, generally speaking, have got higher yields to maturity because investors want to be compensated for the risk that the bond will be called.
Would that one be like the pink line that we saw in the graph?
Now, there was, I think mine was a premium bond. One that was declining. I had not graphed callable bonds at all. Okay, let's try a quick practice problem. Okay, now this is a semi-annual bond. So what will you have to do to the formula?
Double the periods and divide the interest rate in half.
Everyone here, Julian? Double the periods, half the interest rate. Take a crack at that one.
Bless you.
So yield to maturity, so what formula are they going to use? Rate. That's what we use to calculate the yield to maturity. Okay, anyone want to shout out an answer? What did you get, Mira?
2%.
2% exactly?
I didn't put in the decimals with the.
Tell me what your decimals are.
Wait, hold on. I put. At 2.38.
Okay, that's the right answer, but you're not quite there yet. What kind of yield is that? Semi-annual.
Oh,
What do you have to do to that yield?
multiply by 2.
Exactly. And then you get the right answer. So what do we do? We have 10 years to maturity. Periods for year 2, semi-annual, coupon rate is 6.25%, par value is 1,000. So the annual coupon rate is $62.50. So then you simply use the rate formula. We've got 20 semi-annual periods. We've got 31.25, which is the 62.50 divided by 2. We get $31.25 every 6 months. The current price is $1,118. We put a negative sign in because Excel assumes that these are cash outflows. Par value is $1,000. We then calculate the semi-annual yield to maturity as being 2.38%. We then multiply that by 2 to get the annual yield to maturity. Now you could also use the effect function, which is financially, from a financial theory point of view, the better thing to do. But the practice in the marketplace is that bond traders will simply take the semi-annual yield to maturity and multiply it by 2, because the difference between the effect rate and multiplying by 2 is very small. Any questions about this, what I did here? Okay, last thing is to look at the model, which is a very good model for this chapter. And I'm only going to look at chapter 7 because it's the one that's most relevant. You can use this model to answer practically all of the practice problems. And it goes through all of the examples that we've been through today, the basic bond value and valuation model, where you simply put in the year's maturity, the coupon payment, the par value, the required rate of return. It tells you what the values are. It shows how interest rate sensitivity, and I'm going to go down to what, again, this chart, the actual dollars and when you were asking, was it you, Brian, or who asked about the $25? Spencer asked about where did $25 come from. So it's the difference between here and here, here and here, here and here. It's the capital change and the change in the capital loss, the capital gain for the year, based on what the price of bond is at the beginning of the year and the price of bond is at the end of the year. And that just shows you where those numbers come from. They're in the model. And then yield to maturity is calculated for you, the year's maturity, the annual coupon payment, and so on. All the examples that I've just gone through in class are in the model itself, and then the yield to call calculation as well. Semi-annual coupons, essentially, again, what I just did a minute ago, the 28, where you multiply the number of periods times 2, you divide the coupon payment by 2, and that gives you the value of the bond. Or you can get, and then this interest rate risk is an example of that, is used as well to show you that long-term bonds have got greater price risk than short-term bonds. And that's all I want to cover in there. Okay, that's a lot of material. It's very dense. I've gone on much longer than I normally do. I will never take this long in class again because it's a very complicated topic. So are there any remaining questions that people have at this point in time?